Hi guys, today I am going to explain my experiment on the naive-Bayes classification algorithm using Python. In this video, I will explain what naive-Bayesian is, the formula behind it, the dataset used, the program implementation step by step, and finally the output and accuracy. So let's start with the basic concept. Naive-Bayesian is a highly efficient machine learning model. It is a machine learning classification algorithm based on probability. It calculates the probability of a data point belonging to a particular class using prior knowledge of condition. Here you can see that there are three different shapes grouped together and they are classified separately. The important assumption here that all features are independent of each other. That's why it's called naive, because it assumes independence between features even if it in real life they may not be incompletely independent. Naive Bayes works well in spam filtering, sentiment analysis, document classification. Now let's look at the mathematical formula. Naive Bayes is P of C given X equal to P of X given C into P of C divided by P of X. Here the P of C given X is the posterior probability of class given features. P of X given C is the likelihood and P of C is the prior probability of class, and finally P of X is the evidence. Now look at this tabular column. The tabular column tells about the data set, that is the tennis data set. The data set contains the tennis, whether we have to play tennis or not. Here we are using the features, that is outlook, temperature, humidity, windy, etc. And the target variable is play yes or no. The data set tells us whether we should play tennis depending on weather conditions. For example, if outlook is sunny, temperature is hot, humidity is high, wind is false, then play may be yes or no. Now let's move to the program implementation. Before we go to the program implementation, here we used the probability. The total probability equal to 14 and the total yes probability outcome. The number of favorable outcomes of yes is equal to 9 and the number of favorable outcomes of no is equal to 5. So hence we choose the maximum number of favorable outcomes equal to 9 by 14. Hence we play tennis. Now look at the program. First we just needed to import the necessary libraries. First start with pandas. Pandas is used for handling data set and the sklearn library is used to split the data into training part and testing part. Hence train test split is used to split the data. And the library Gaussian NB is used for naive-Bayes model. Label encoder converts categorical values into numbers. And lastly, the library accuracy score is used to calculate model accuracy. Next, we have to load the dataset. Before we load the dataset, we have to get the required CSV file from the reputed website. So, we have to find a website that gives a real and workable CSV file. So, let's go to the website called Kaggle. Kaggle is a website that contains a lot of dataset. So, we just needed to get the proper dataset from that website. Just go to the Kaggle website and search tennis.csv. After searching tennis.csv, just click at the link. As you can see the download button at the top right corner. Just click download and wait for the dataset to complete download. Open the file location of the dataset. Before importing the dataset, just perform a basic analysis of the dataset, whether it is correct or not. If there are any mistakes found, just correct the data using your knowledge. Here you can see there are various parameters of the data. Next, we have to right click and copy the location of the dataset. Just copy as path and go to the function called load data of function. In the load data of function, as you can see that there is a line called df equal to pd.read csv of function. Just paste the location in that line. After pasting the location, next we move to the next function called def preprocess of data. Preprocess of data is used to convert the categorical values like sunny, hot, I, yes or no into numerical values using label encoder. Okay, machine learning models cannot understand text. So we convert them into numbers. Okay. We encode all features columns and also the target column. Then we return encoded data frame and encoders. Next, we have to split the data into two parts. We have to split the data into training part and the testing part. So there is a line called x is equal to df dot I log of colon comma colon minus 1 dot values of, and the next variable declaration y is equal to df dot I log of square bracket colon comma minus 1 dot value. These are the variables that contains the column features. X contains the input features and y contains the output, that is players column. Here the data is converted into either matrix form or array form, and they can be encoded into the binary digits so that they can be easily splitted and tested in a classification model. Next, we move to the train test split. Here, we split the data into 80% of training data and 20% for testing data. Training data is used to train the model and testing data is used to evaluate the accuracy. Here you can see x underscore of train, comma x underscore of test, x underscore of train, x underscore of test is equal to train underscore test split of function. Here the function is looped through arrays and converted into encoder values. Next, we have to train the model. In order to train the model, we use a variable declaration called model equals to Gaussian NB of function. Gaussian NB of function is a predefined library used in Python. Model.fit of function is used to fit the training data model. X comma train, x comma y comma train. These two variables are encoded into model.fit of function. We create a naive Bayesian model, then train it using train data. And finally, we have to predict the accuracy of the model. Y underscore predict equal to model.predict of x underscore test, and accuracy equal to accuracy underscore square bracket of y test underscore y predict of function. These are used to predict results using test data and compare predicted output with the actual output and calculate the accuracy. Next, we finally move to the output area. As you can see, the first value of the training data original, this shows the data set before encoding values like youth, high, no, fair. These are original categorical values, and the next five values of training data are the original data, yes or no, and these are encoded into zeros and one. And finally, you can see the model output is accuracy is 1.0, and the final model accuracy is 1.0, which gives a better result. Thank you for watching.